Hello everyone. In this video we're going to be solving a nice trigonometric equation, or an exponential trigonometric equation, I should say. We have tangent x to the power sine x equals cotangent x to the power cosine x. And we're going to be solving for x values. So I'm going to go ahead and turn this into a nicer form and then solve the resulting equation. And then we're going to come up with an other trigonometric equation, which we're going to solve in two different ways. So first we're going to apply one method, but then we're going to split up into two ways. All right. So first of all, I want you to notice that we have to start with the bases. I have tangent x and I have cotangent x. And what are they? They are reciprocals. So in other words, cotangent x can be written as 1 over tangent x, as long as tangent x does not equal 0. All right? So these are reciprocals, so what can I do with that? I can replace cotangent here with 1 over tangent. Let's do that. Tangent x to the power sine x equals 1 over tangent x to the power cosine x. 1 over tangent x is just tangent x to the power -1. And don't confuse this with tangent to the power -1x. This is the arctangent, which is the inverse function. But when I write the tangent in parentheses and put the -1 on the outside, it's not the inverse function anymore. It is the reciprocal. Make sense? Hopefully it does. I just wanted to clarify that real quick. Now we got a nicer equation because our bases can be made the same. Let's go ahead and multiply -1 times cosine x. That's what the rule says. So we get tangent x to the power sine x equals tangent x to the power -1 times cosine x, which is negative cosine x. Cool. Now, we have the same base, so we can kind of proceed in an easier way. If we didn't have the same base, we could log both sides, and we could still log both sides. Even if when you have the same base, you can do it. I don't know if it's going to be easier. Possibly, I don't know. But you could do that. But when you do it, you have to make sure that you stick with the domain. Okay? Because log function does not allow negative numbers, at least for reals. But then complex solutions allow that. And the original equation can also have negative base. Maybe it doesn't, but we'll find out. So what do I do from here? I have something like a to the power b equals a to the power c. And if a and b are real, a, b, c are real numbers, especially a in this case, then we can proceed as follows. Either b is equal to c, and obviously in that case a and b, a can be anything pretty much, right? Or I have a equals 1, which again bc can be anything, because if base is 1, then we're all good. Or the base can be -1. And if the base is -1, then we have to be careful, because b and c must be what? Positive, not positive, even integers. Why even? Because even or both even or both odd, I should say, because here's the thing. When you have a -1 on both sides, okay, let me write it first, both even or both odd integers. And the reason for that is, if you have -1 on both sides and you're raising them to different integer powers, you don't want this to be like 2 and 3, because they're not equal. One of them is +1 and the other one is -1. So they're both even, means 1 equals 1. Otherwise, it's -1 equals -1. Okay, under those conditions, let's go ahead and take a look at this equation. I'll start with the equality of, well, not equality. I want to start with the second one, a equals 1. So suppose tangent x equals 1. In this case, I have solutions. I don't care about b and c. But this just means x equals pi over 4 plus n pi. Remember, the period for the tangent function is pi, so we're going to add multiples of pi, right? All right, cool. So this seems to be working. What about -1? What happens if tangent x is -1? Then we get x equals, now if you think about the unit circle, this is where tangent is +1. This is where tangent is -1, right? And if you draw the axis, tangent axis, it should go like this. Anyways, something like that. Hopefully you get the idea. But tangent is 1 when it's pi over 4, at 3 pi over 4, the smallest value for which tangent is equal to -1. So we always go with the smallest because we're going to add multiples of pi to it anyways. Make sense? So these are the solutions, but here's the problem. When tangent x is equal to -1, we get something like -1 to the power sine x equals -1 to the power cosine x. And so sine x and cosine x both have to be even or odd integers. But when x is this, cosine and sine are not going to be integers, right? So this is not going to work. So we can only go with this for now. That's going to be part of the solution. Now let's go ahead and proceed with the first case, which we left for last, or saved for last, because that was the most interesting one. So now one more time, our equation is tangent x, and I'm going to give you the modified version so we don't have to reinvent the wheel. So this is our equation with the same basis, and now I'm going to go off of the exponents. The exponents are supposed to be equal, so that implies sine x equals negative cosine x. There's actually more than 2 ways to solve it. I told you initially that I was going to present 2 methods, but if I have time left, I don't know, I don't want to take too long because the other video was already too long anyways. I might present the third method. The first method is the following. First method for solving this equation. You could also guess and check on this one, but anyways. The first method is kind of interesting because it's a lot of times it's used for equations like a sine x plus b cosine x equals c. So these types of equations can be solved with the first method. So multiply, don't multiply yet. Okay, I'm kind of rushing and ahead of myself. Okay, first of all, put the sine and cosine on the same side by adding. And then multiply both sides by √2/2, which you're going to see in a little bit why. Okay, it's still 0. Now go ahead and distribute √2/2. By the way, √2/2 is something we know, so we should be familiar with that. So I'm going to write it as sine x multiplied by √2/2, and I'm going to be selective here. √2/2 times cosine x. Why did I write it that way? You'll see in a little bit, because I'm going to use an identity. And that identity is the sum and difference identities. Now I want to write √2/2 as cosine pi over 4 and √2/2 as sine pi over 4, which is interesting because you can write different things for the same thing. Now this becomes sine alpha plus beta. Do you see what I see? Sine alpha cosine beta plus sine beta cosine alpha. So this is sine x plus pi over 4 equals 0. And yay, the sine of each angle is 0, and the answer is multiples of pi. Any multiple of pi, because pi, 2 pi, 3 pi, they're all going to work. So I'm just going to write it as m pi. From here, we can write this as x equals negative pi over 4 plus m pi. Or if you wanted to write it in a, I don't know, more compact form, you can also write it like this. If m is 1, then x is just going to be, what? 3 pi over 4. Awesome. That's just one of the solutions, but this is the general solution. All right. Let's go ahead and take a look at the second method. Second method also picks up from here. And now for the second method, I want to square both sides. A lot of times squaring introduces extraneous solutions, but here we don't have that issue because 0 is not going to be affected. But anyway, sine squared x plus cosine squared x plus 2 sine x cosine x equals 0. This is 1, you should know that. And this is double angle, sine 2x. And from here we get sine 2x equals -1. And this has a nice solution. This means 2x is equal to pi over 3 pi over 2 plus t pi, right? Actually 2t pi because that's sine. And from here we can multiply both sides by 2 and get x equals 3 pi over 4 plus t pi. And if you replace t with 0, you get x equals 3 pi over 4 as before, and obviously other values are going to give you different values. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. And the third method, let me just tell you real quick, you could multiply sine and cosine, divide by that, and this is going to give you tangent, and you could just go off of that. Bye bye.